In this question, we're going to look at comparing probabilities calculated with a normal distribution and a t-distribution. We're told that the number of Summer Olympic medals won by a particular country are normally distributed with a mean of 93.7836 and a standard deviation of 40.6317. First thing we'll do is transfer that information over to Desmos, so we have a mean of 93.7836 and a standard deviation of 40.6317. We can open up our normal distribution calculator and turn on the visualization for that distribution and calculate the probability that x is less than or equal to 130. Then we can export that value to make sure we can appropriately round to 4 places. We would get 0.8136. In parts B and C, now we want to use the t-distribution to find the same probability, and we're given an additional piece of information that we need for the t-distribution, which is the degrees of freedom. So where we have df, we'll plug in that value for our degrees of freedom, and then we can open up the t-distribution calculator, and this will work very similar to how the normal distribution calculator works. We can turn on the visualization for that tool. We can zoom fit between those two different distributions, but the pictures are fairly similar. And we again want to calculate a left probability so that x is less than or equal to 130. And that corresponding probability would be 0.8061. Part C is exactly the same probability statement, but now the degrees of freedom have changed from 14 to 18. So we'll go back up in this tool to change df to 18, and our new probability will be 0.8077. What we can see from these two values is that with 14 degrees of freedom, we're getting kind of close to the value we had in part A, but as our degrees of freedom increase, our probability is getting closer to the probability that we calculated in part A with the normal distribution. And as we continued in that pattern, if our degrees of freedom got larger and larger, we would continue to get closer to that value from part A. So we can say the probability calculated by the t-distribution gets closer to the probability calculated by the normal distribution as the degrees of freedom increase.